Hi, everyone. My name is Andrew Butterfield. I'm the Senior Product Manager at Oracle Cloud Infrastructure, responsible for our high-performance computing and GPUs. Today, I'll be presenting on our high-performance computing service on Oracle Cloud Infrastructure. In this presentation, we'll cover high-performance computing on Oracle Cloud Infrastructure, comparisons and differentiators, OCI for HPC workloads, performance, and the HPC economics in the cloud. Oracle has a history of acquiring companies that produce the highest performance and most quality hardware for hosting enterprise applications. In 1994, we purchased the RDB division of Digital Equipment Corporation to run our database products on high-performing VACs and VMS mini computers. In 2010, we purchased Sun Microsystems. As part of that acquisition, we got access to some of the best hardware for high-performance computing with Mellanox cards and InfiniBand technology. In 2016, we launched our first bare metal offering on the cloud, and then expanded this offering to include a specialty HPC shape with Intel X7 processors and GPU shapes with Pascal and Volta NVIDIA GPUs. Our offerings will continue in 2020. We plan to release our new generation of X9 HPC shapes with Intel X9 processors, our E3 shapes with AMD Realm processors, and our third generation of GPU shapes using NVIDIA Ampere. Our OCI regions include both government regions and commercial regions. In 2018, we started out with just 4 regions. By the end of 2019, we had 17 regions, launched with 7 of those providing HPC or GPU specialty shapes. Additionally, we partnered with Microsoft to provide regions where you can deploy an interconnect to access Microsoft Azure from Oracle Cloud Infrastructure. This interconnect is great for customers who are using Oracle database and want to pull that data to their Microsoft Azure systems. And it is also beneficial for customers who are using our compute and want to move that data into Microsoft Azure, so the interconnect allows them to do both. Our footprint globally is growing rapidly. By the end of 2020, we will have 36 regions launched, with 14 of these regions containing HPC and GPU offerings. Comparisons and differentiators. Why high-performance computing is better on Oracle than other clouds. OCI provides a better high-performance computing platform than other clouds because we offer true bare metal. Other cloud providers may market bare metal. However, there is often some sort of hypervisor overhead, or it is not a single-tenant offering, meaning it isn't dedicated to you. We offer true bare metal without that hypervisor layer and without any Oracle software installed. We provide just the infrastructure so you can connect to it and configure it as you would an on-premises server. In our cloud, we provide a better price performance than other cloud providers, and we have benchmarking data to back this up, particularly for our HPC shape. We also have shown that we can match or surpass the performance of on-premises environments. We have done many different customer proof of concept tests to show that we are more efficient than our on-premises environments, and this is using a wide variety of simulation software from CFD to molecular modeling to crash modeling software. For storage, we offer 6.4 terabytes of local NVMe SSD storage, which is more than any other cloud provider. For customers that need additional storage, we offer elastic block storage volumes, which can provide up to 32 terabytes each and up to 35,000 IOPS per volume. Lastly, we have shown that parallel file systems have a higher throughput on OCI than on other cloud providers. This includes commonly used file systems such as IBM Spectrum Scale, Lustre, GlusterFS, VGFS, and others. OCI provides a specialized network that is not oversubscribed, so you won't be getting a lot of noisy neighbors affecting your performance. It's also a flat network with 25 gigabits per second bandwidth and is the only cloud with a network performance SLA. We guarantee that your resource performance should be greater than 90% of the published performance 99% of the time. Lastly, we also provide a 100 gigabit per second RDMA network to run tightly coupled workloads across clusters of HPC nodes. This RDMA network has high bandwidth and ultra-low latency that can go as low as 1.5 microseconds, which we will talk about in the next couple of slides. In regards to networking, we have implemented a flat, bare metal network that supports dual 25 gigabit per second Ethernet for fast front-end access to your compute clusters. At the foundation of the infrastructure, we have a region with data centers. Within each data center, we have up to 3 availability domains, as well as fault domains built into the ADs for high availability. In the physical network, the connections between the servers and the rack are set up to minimize the number of ports that are required. This means that there is no instance that isn't more than 2 hops away from another instance. This allows you to get low latency and high throughput access to those instances by the way they are meshed together. On top of that, you have your virtual network. Oracle Cloud Infrastructure is the first cloud platform to implement off-box network virtualization. Off-box virtualization means virtualization is no longer committed into the hypervisor. It's now engineered into the network outside the physical box. It gives the ability to plug resources like compute instances or storage directly into the network without making changes to the network. Within the virtual cloud network, you can define your IP addresses, subnets, route tables, security lists, gateways, and other network attributes. The top layer are your services that you can provision within your virtual cloud network. This includes compute instance, block storage, Exadata, autonomous DB, and other services that Oracle Cloud Infrastructure offers. As stated in the previous slides, we're the first cloud provider in the industry to provide a true bare metal instance in the cloud. We're also the first to provide a production-ready RDMA network for bare metal instances in the cloud. In this configuration, servers are connected directly to the RDMA switch and there is no hypervisor, no virtualization, and no jitter. In other clouds, data has to go through a VM and a hypervisor before it can access the underlying server hardware, and the VMs are distributed across the entire data center. This adds significant latency and unpredictability in performance. OCI's RDMA network allows customers to configure compute nodes into a high bandwidth, ultra low latency network that can go as low as 1.5 microseconds. Each node is connected in a way that simulates a hardwired connection, similar to servers in an on-premises environment. This type of networking is targeted for complex product development workloads such as CFD modeling, crash simulations, reservoir modeling, DNA sequencing, and others. It is particularly useful for running tightly coupled workloads which divide and distribute jobs among clusters of nodes for efficient processing. Currently, we offer RDMA networking for our HPC bare metal shape, and RDMA for our GPU shapes, Exadata, and block storage are planned. Our Intel-based HPC shape comes with 36 cores and cluster networking capability using Rocky V2 to run tightly coupled workloads with low latency. It has the highest CPU performance in the cloud. This shape is suited for applications that can only run on CPUs and need a cluster network with low latency to minimize processing time. Our second generation GPU provides 52 CPU cores and 8 V100 GPUs for higher processing power. Our GPU pricing is much less than other cloud providers, at $2.95 per GPU per hour. Our AMD shape uses AMD EPYC processors and provides slightly less performance than our HPC shapes, but at 3 cents per core per hour, the shape is suited for customers who are able to trade some loss in performance with significant cost savings. Our next generation of HPC shapes includes our Intel-based HPC shape, which will feature 14 gigabytes of memory per core and RDMA interconnectivity. Our third generation GPU will be generally available by the end of summer and will feature a powerful AMD CPU with 64 cores and 8 A100 GPUs. It will utilize RDMA cluster networking, originally built for Exadata and HPC compute to support workloads like machine learning training and visual effects rendering. It'll be priced at $3.05 per GPU per hour. We also offer 5 different high-performance computing file servers, such as IBM Spectrum Scale, BGFS, LusterFS, Weka.io, and Lustre. We have the highest price performance for our HPC shape in the cloud today. Compared to our competitors, our HPC shape has the lowest network latency as previously mentioned. We also have more memory per core in our HPC shape, more local NVMe storage, and consistent pricing. Diving into the specifications of our HPC shape comparison, we offer 6.4 terabytes of local NVMe SSD storage, which is more than GCP, AWS, or Azure. Additionally, we offer the most memory per core at 384 gigabytes and 100 gigabits per second RDMA networking using Rocky V2. OCI for HPC workloads. OCI provides both high-performance computing cluster networking for tightly coupled HPC configurations and HPC instance pools for massively horizontal HPC configurations. The types of applications that are often run using HPC cluster networking include computational fluid dynamics, finite element analysis, crash simulation software, weather modeling, seismic processing, genomic simulations, and astrophysics and deep learning simulations. The types of applications that don't need low latency cluster networking and can be run just on standard HPC instance pools or GPUs include risk simulation, molecular modeling, contextual search and logistics optimizations, rendering, and semiconductor verification for electronic design analysis. We have customers in research and academia that use our HPC for a wide variety of applications. Here are a couple of examples. For big data, we're partnering with Kinetica to provide a GPU-accelerated data platform on OCI. Through this partnership, we're providing a platform for the San Francisco Estuary Institute to execute machine learning algorithms for trash detection in the San Francisco Bay. We also have several research customers performing fluid dynamics simulations using our HPC shapes for a wide variety of purposes. This allows our customers to solve physics models sooner and scale up capacity as needed, depending on the requirements of their jobs. Lastly, we have research customers in the genomics and molecular modeling fields. One of our customers, Bristol University, is evaluating the effects of nicotine binding on brain receptors to identify drugs that will allow smokers to quit. Other customers are using our platform for COVID-19 research to identify drug binding sites for the disease. A great financial services customer on Oracle Cloud Infrastructure is BJSS, which is a UK-based firm that provides high-frequency trading to their customers and utilizes the ultra-fast and low-latency RDMA networking for their customers. For the Italian Financial Services Laboratory, which provides guidance for the EU, Oracle Cloud provided a 10% reduction in training times compared to their on-premises supercomputer. OCI recently onboarded a new customer that's a global auto manufacturer. Our bare metal HPC service outperformed two other cloud vendors and also outperformed on-premises providers. We were able to get them deployed just 3 weeks after the deal was signed and had them running their crash and internal engine airflow simulations on a 25,000 core system with a 10,000 core capacity for burst workloads. Denso Technologies gained an improvement of 5 times or more in their calculation speed on Oracle Cloud High Performance Computing than their on-premises system for their application for fluid noise analysis. Dr. Nikolai Petrovsky at Flinders University was able to take the genomic sequence of COVID-19 and utilize Oracle Cloud Infrastructure to analyze and characterize the key viral attachment molecule called the spike protein. Performance. As previously mentioned, Exhibitor evaluated our HPC shape against our competitors, AWS, Google, and Azure. They compared Oracle's high-performance computing shape to the equivalent of our competitor shapes. The following benchmarks were run. High-performance LinPack, which is a benchmark implementation to qualify a system's computing power. VASP, which is a molecular modeling software. The criteria analyzed were speedup, which is the efficiency of the application, performance per core, network bandwidth, and latency. You can see on the right, using VASP benchmark, that the speedup was much higher on OCI at all node counts than other cloud providers. Our high-performance computing file servers are built on our bare metal, non-oversubscribed front-end TCP network. Our high-performance block volumes scale and provide replication and failover automatically. For even higher performance, users can leverage local NVMe and RDMA on our cluster network and see over 140 gigabytes per second performance. HPC economics in the cloud. When measuring the price performance for high-performance computing workloads, it's important to look at the cost of a single job. On a per-job basis, cloud is much cheaper and easier to manage than on-premises. With Oracle Cloud Infrastructure, our pricing is predictable for the latest generation of hardware. You can always expand or shrink your capacity with no lead time or capital expenditure. Because of Oracle Cloud's bare metal network and RDMA cluster networking performance, high-performance computing jobs can be run cheaper and quicker on Oracle Cloud. Oracle's network technology enables flat costs as the network scales. The example at the right is for a computational fluid dynamics model that is 140 million cores. While the number of cores increases, our networking performance stays consistent. The total cost of ownership, or TCO, for high-performance computing workloads is something that gets discussed and debated all the time by anyone involved in high-performance computing. When we compared Oracle Cloud Infrastructure's high-performance computing service for an high-performance computing workload using primarily CFD simulations over 3 years, we came in at 36% less expensive than our on-premises competition. That's because with OCI, you're only paying for the compute and the storage, whereas with on-premises systems, you're on the hook to pay for compute, storage, networking, and admin. The total cost of ownership for Oracle Cloud Infrastructure's HPC service becomes even more compelling when you start to factor in additional costs, such as facilities, hardware acquisition, installation, and deployment. As a cloud provider, we launch new instances running on the latest hardware every year. Most on-premise systems acquire the best system they can get that year and are stuck with it until their next refresh cycle years down the line. For HPC applications on Oracle Cloud Infrastructure, that means potentially a 7x performance increase over 5 years. High-performance computing economics isn't only about compute. File servers are an important aspect as well and can be a challenge to run on premises. Oracle Cloud Infrastructure is the only cloud provider that has the ability to scale instantly with network and storage service level agreements. So try it out for yourself and spin up an HPC cluster today or deploy a GPU. So the key takeaways are that OCI is the first cloud provider to offer true bare metal instances for high performance computing applications in the cloud. OCI HPC provides better price performance than any other cloud provider and comparable or better performance than most on-premises environments. OCI HPC is used for all types of HPC workloads, including financial services, computational fluid dynamics, and big data. Thanks for your time.